The $10 million Alamosa Water Treatment Facility, engineered by Richard P. Arbor Associates for the City of Alamosa, allows the city to achieve compliance with the U.S. Environmental Protection Agency's arsenic rule by removing arsenic from the city's otherwise pristine groundwater wells. Timing for this project was crucial, as after nearly 7 years of planning, design, and just months prior to the completion of the new 5 million gallon per day water treatment facility, more than 390 salmonella cases were reported and linked to the water system. This was the first significant event experienced by the water system in over 100 years of operation. The City of Alamosa Water Treatment Facility uses a process that adds a coagulant chemical to bring the arsenic out of solution so that it can be filtered out by a membrane. The use of the coagulation membrane filtration process to the city's well water is one of the first facilities in the nation to apply this technology for arsenic removal. Social impacts to the community were minimized by constructing the water treatment facility at the site of a historic railroad and industrial storage and transfer station. The use of the low-energy motors, lighting fixtures, and equipment, along with the construction of a raw water delivery system to provide raw water irrigation, reduced chemical and power use. Today, arsenic levels are now consistently well below the allowable level, and the plant is using only half of the coagulant chemical that was expected based on earlier pilot studies. The water treatment plant will also provide the engineering profession with a real-world operating data for further refinements while achieving exceptional water quality through low energy consumption and reduced chemical usage.
The City of Alamosa Water Treatment Facility was a project that needed to happen for this local community of Alamosa to meet more stringent federal guidelines around arsenic. The completed water treatment facility was constructed on a reclaimed brownfield site that had previously been used as a diesel transfer station for 2 regional railroads. One of the things we talk about in sustainability is avoiding building on land that hasn't been built on previously, so really using existing infrastructure. So this is a really great example of building on a brownfield site. One of the other things they did is really important from a water conservation and water consumption perspective. So the new facility has 2 complementary water systems. One's focused on raw water and one is focused on finished or treated water. The raw water system was constructed with connections at parks and golf courses so that those facilities could provide raw water irrigation without the cost of unnecessary treatment. The finished water system was expanded, allowing for regionalization at an economical cost. The result of these strategies together is the reuse of a previously developed site, a safer water source for the community, and conservation of water by creation of the raw water system.
In Colorado, dozens of public water systems are affected by naturally occurring low-level radioactivity in their groundwater supplies. These water systems are found in small, rural communities which lack the technical and financial capacity to comply with new regulations that are revising drinking water standards. Engineers Malcolm Perney Incorporated was retained by the Colorado Department of Public Health and Environment to launch a precedent-setting program, the Colorado Radionuclide Abatement and Disposal Strategy. The program evaluated comprehensive radionuclide compliance options and provided technical expertise free of charge. The engineer engaged local and national experts to develop sustainable and financially viable solutions to achieve compliance and protect the health of consumers in these communities. The process involved policy development assistance, groundwater sampling, treatment technology evaluations, radioactive waste disposal evaluations, workshops, innovative bench and pilot scale studies, and engineering report development. As a result of this project, 33 affected small water systems now have detailed system-specific information to support the selection and implementation of a radionuclides rule compliance strategy. This will help reduce the impacts from radioactive treatment residuals. Ultimately, this research will benefit the public health of more than 31,000 Colorado residents, the environment, and will also provide a model to help water systems nationwide to comply with this challenging regulation.
Over 40 public water systems in Colorado are affected by naturally occurring radionuclides, and most of these communities are small and rural, and they rely on groundwater supplies. This is a concern because, of course, radionuclides are radioactive materials that can affect the health and well-being of humans. Many of these communities lack the technical and financial capacity to remove and manage radioactive material, and they were in violation of maximum contaminant levels for radioactive contaminants in drinking water as defined by the federal government. In response to this problem, the Colorado Department of Public Health and Environment recently launched the Colorado Radionuclide Abatement and Storage Strategy, or CORADS. The goal of this project was to evaluate radionuclide compliance options for these small communities and to provide technical assistance to the affected communities free of charge. As a result of this project, 33 affected small water systems now have detailed system-specific information to support the selection and implementation of a radionuclides rule compliance strategy that will help reduce the impacts from radioactive treatment residuals and the tools to support successful applications for funding. This project will ultimately improve the health and well-being of over 31,000 Colorado residents and will increase local capacity to ensure a safer water supply. This project will serve as a model for other parts of the country that are facing the same issues.
Following the extensive loss of life and property from Hurricane Katrina, FEMA is now requiring many cities to recertify their levees and flood control systems. The city of Wichita, Kansas, which has an extensive levee system, selected Engineers American Company to provide high-resolution light detection and ranging, or LiDAR, digital aerial photography, and arc hydro stormwater modeling services for its levee recertification application. Located in the Arkansas and Little Arkansas River valleys, the region is very flat and interwoven with canals that move water both during base flows and periods of flooding. Supporting these canals are 97 miles of levees, which were built in the 1950s as part of the Wichita Valley Flood Control Project. Data was collected over a 1,000 square mile area with a focus on a 33-mile stretch of the Arkansas River consisting of levees, floodways, improved channels, and control structures. By using advanced geospatial technologies for recertification, the geodatabase created can be used to identify areas likely to flood or retain runoff, design culverts and bridges, identify pathways of flood flows, assist in new development site plans, and support overall stormwater mitigation. As one of the first congressionally mandated levee recertification projects in the U.S., this sets a standard for accurately and scientifically substantiating engineering decisions for other FEMA levee recertifications. And it provides the public increased safety, protection of property and lives, and preservation of the social fabric of the community.
After Hurricane Katrina, FEMA began requiring cities to recertify their levees and flood control systems. The city of Wichita, Kansas is located in a flat region with interwoven canals and 97 miles of levees, all of which contribute to a constant threat of levee failure and a history of significant flooding across the region. After one flood, the federal government found that the lack of detailed and relevant data meant that emergency management personnel had difficulty in quickly identifying areas affected by flooding and therefore could not notify affected residents in a timely manner. The use of engineering plans based on scientific geospatial data informed the recertification of levees in Wichita through this project. This provided the public with increased safety and protection of property and lives. Scientists predict that climate change will increase the possibility of severe weather and flooding over time. As we work to adapt to the impacts of climate change, scientifically substantiated strategies for flood control will become increasingly important.